Hello everyone, welcome to the next lecture on the PY question series. Today I will explain you how you can solve the questions related to the function and its various feature. Myself Dr. Harish, you can simply follow my YouTube channel where you can find the playlist of the CSR UGC net. You can find the various lectures available here. There is one more playlist of the IIT Jam and you can see the various PY questions. All are explained with the help of the shortcut trick. If you are new to my YouTube videos, you can scan and join my WhatsApp group and join with me if you are only from the IIT Jam students. Now, let's start with this question. So, remember that I will give you the several tips in this lecture so that you can solve each question with the help of the 10 to 15 second time period. Number one tip, whenever you are talking about the number of the roots, fine, whenever you are talking about the number of roots, there is always apply the discard rule of sign. Always apply the discard rule of sign. Second tip is whenever your function fx is odd degree, then there exists always, fine, there exists always one real root. Fine, whether the roots is my positive or negative, but there is always existence of that. Now look at that, the number of the real roots, the degree is my odd, so 0 is the number of the real roots, is a cancel out because of this option. Now how you can find the actual number of the roots? I can apply the discard rule of sign. So I consider this is my fx, fine. So firstly find the number of the positive roots. What will be the number of the positive roots? You can count the number of the sign. This is the positive, this is positive, this is negative. Only one change in sign, so it's a one, at most one positive root appears. Find the number of the negative roots. How you can find the number of negative roots? I can find the value of f of minus x. It's a minus x cube minus x minus 1. You can see there is no change in sign. Fine. So there is no change in sign. It means the number of the negative roots are my 0. But the degree has 3. It means the remaining one is my complex roots. So degree is 3, 1 is there. So complex roots are my 2. So what is the number of the real roots? At most 1 is the complex number of the roots. It can never be 0 because if it is a 0 number of the positive roots, I have a 0 number of the negative root. It means all are my complex root, but complex roots always occur in the pair. So it can never be 3. Complex roots are always in the even number. So that's why the maximum number of the real roots are my 1 is the right answer. Again you can see, again the degree is my odd. So at least one real roots are there. Fine. So then if I consider this is my fx, so can you find the number of the positive roots? So is there any change in the sign? There is no change in sign, so 0 number of the positive root. What is the negative roots are there? I can find the value of f of minus x. It is minus x raised to power 9, minus x raised to power 6, x raised to power 5, x plus 1. So clearly say there is one change in the sign. So it has a 1 at the most negative roots. So what is the complex roots? So degree is my 9. So 9 minus 1, 8. So what is the right answer of this? Number of the real roots, 1 is the real roots. Again, it can never be 0 because if negative roots are also 0, then the complex root will be 9, which is not even. So therefore, the maximum number of the distinct real roots is my 1, and that is my negative root. Look at this another one. Which of the following is the value has the 3 distinct root? Again, I can find the number of the positive roots firstly. How many positive roots are there? One change in sign here. That's it. So that is a 1 at the most root. What is the number of the negative roots? I can change the sign of this. It is my minus 2x cube plus 3x square plus 12x minus k, because k are all my positive. So there is one change in sign, one change in sign. So the number of the negative roots are my 2 at most. Fine. Now I can draw it graphically. So it means it has a 2 negative root at most. This is my negative, 1 positive root. What is my f of 0? f of 0 is my minus k, that means this number is my here. So what is the graph of this? It has the two negative roots, this one here and this one. This is the graph of the fx. Now what is the value of the k? That's a very simple. How you can find this maximum value? How you can find this minimum value? The corresponding point is, this point is called as critical point. Fine. Now I can find the critical point. What is the definition of the critical point? F dash is 0. So that means 6x square plus 6x minus 12 is 0. That is x square plus x minus 2 is 0. So x will be minus of 2 and plus 1. So definitely this number is my minus of 2 and the corresponding this number is my plus 1. Now what is the f of minus 2? From the graphically clearly say f of minus 2 is my positive. So if I substitute here, it will be 8 16 plus 4 12 minus plus 24 minus k is greater than 0. So that means 20 minus k is greater than 0. So that means k should be less than of 20. Strictly less than 20, that means 16 is the right answer of this problem. Because f of minus 2 is strictly greater than 0. Or you can also see from here, what is the f of 1? It is less than 0. So if I substitute 1 here, it will be 2 plus 3 minus 12 minus k is less than 0. So that means 5 minus 7 minus k is less than 0. So that means minus k is less than 7. K should be greater than of minus 7. So k should be greater than minus 7. All are satisfied. But from this, it is only 16 will be satisfied. Or you can see I got the number as minus k less than of 20. Fine. So which is the only satisfied. Okay, which of the following is my true? Okay, there are several tips for you. Firstly, I will tell you what is the how you can check about the 1 1 graphically. For example, if you draw the graph of the y is equal to x square, fine. How you can check the 1 1? You always draw the horizontal line. Fine. If you draw the horizontal line, if it cut it more than 1 point, if it cut more than 1 point, then it is not 1 1. Fine. So it cut more than 1 point, it is not 1 1. Again, if I consider the y is equal to x cube, what is the graph of this? Here, if you draw the horizontal line, it cut only 1 point. So yes, this is 1 1. Fine. Otherwise you can also check about that f of x1 is f of x2 and your target is to prove x1 is equal to x2. Fine. This is the second way. There is one more way. If you draw it graphically, that is very good. This is the mathematically. Otherwise, there is one more tip is if the critical point lies in the domain, fine, then the function is not 1 1. Fine. There is one more tips related to the 1 1 is if the function is continuous as well as the monotonic. If the function is continuous as well as monotonic, then f is 1 continuous on some interval I, then f is 1 1 on that interval. Remember, it's a monotonic. It may be increasing or decreasing. Fine. Now, firstly, can you find the number of the positive roots? So there is a 2 change in sign, so at most 2 roots. Number of the negative roots are, if I change this one, is a minus 2x cube minus 9x square plus 7. So it has a 1 negative roots. So the graphically representation is 1 negative, 2 positive. What is the f of 0 is? 7. That is my here. So the graph will be look like this one. Fine. So this value is my f of 0 and 2 negative roots are. Now, clearly say when you take minus 1, 2 plus 1, so minus 1 either this side, this side, this side. But if you draw it graphically, if you draw the horizontally, definitely it cut the 2 point. So it means this option is not 1 1. Fine. Otherwise, you can also see I can find the critical point of this. f dash is 0. What is the f dash 0 is? 6x square minus 18x is 0. So the critical point is 0 comma 3. Fine. Again you can see 0 belongs to this. Fine. So if the critical point belongs to the domain, f is not 1 1. 2 comma 4, critical point 3 belongs to this, so it is not 1 1. It is not 1 1 in the interval minus 4 comma 0. Again you can see 3 is belongs to this, so f is not 1 1. Fine. So this is the correct statement. F is not 1 1 in here, minus 4 comma 0. So 0 is here, minus 4 is something here. If you draw the line, it cut it only at the one point. So this is a 1 1, but he said it is not 1 1. So the right option is D is the right answer. I can discard this option by graphically. It is a 0, somewhere is a minus 4. Fine. Either this is minus 4 or this is minus 4 or this is minus 4. But whenever you draw the horizontal line, it cut it only at the one point in either of the side. So it means this is not 1 1 is a wrong. It is a 1 1. So the right answer is D is the correct answer. Okay, which of the following is also, which of the one is not 1 1? Again, can you do it graphically? It is not possible for you to graphically. I can found the critical point. So what is the critical point? Is there 1 over minus 3x4. So x4 will be 3. So x will be my plus minus 3 raised to power 1 over 4. Fine. So can you, do you have a calculator? You can find the value of 3 raised to power 1 by 4. So I will calculate it. It's come to be 1.316. Now can you find the number of the positive roots? So there is no change in sign. What is the negative roots? It's a negative, it's a negative. Again, there is no change in sign. Fine. So it's a plus 1.36 and minus 1.36. What is the f of 0? 0 has a no defined. Now, minus 1.36 is lies in this domain. Fine. This minus 1.36 lies here. So this function is my not 1 1. But he said 1 1. Again, you can see from here, minus 1.36 lies in this domain, it is not 1 1. 1.36 lies in this domain, it is not 1 1. Both these critical points does not belong to this, is the right answer. So you can see it's a very simple if you remember my this shortcut tricks. If the critical point lies in the domain, then it is not 1 1. Okay, look at this another one. Again you have the equation. Find always the number of the positive roots. Find the number of the negative roots. So find the number of the positive roots. There is only one change in sign. 1. Find the number of the negative roots. So first number will be minus x raised to power this. Second will be positive. Fine. Then it will be the negative 2019 and so on. The last number will be minus x minus 1. Fine. So how many? That's an alternating change in sign. There is an alternating change in sign. So can you find the number of the negative roots? So what is that? No real root is positive. That's wrong. We get at least one real root as a positive. Exactly one real root is negative. Exactly one real root is positive. Exactly one real root is positive. How you can say about that? All the real roots are my positive. Now see, I will tell you one easiest way because I am unable to count the how many change in the sign here. Okay, I will tell you the simplest approach. Look at the function. Firstly, we all know if you have the function of odd degree, what is the graph of this? Graph will be look like always like of this one. If it is a y is equal to x, y is equal to x cube, it will be here. Whenever it's an even function, then it will be always like a parabola. Fine. Whatever the degree is there, you can see the degree is my odd. I can change this function to be odd degree. That is simply I can taken as x minus 1. I will solve this question like here. Fine. The behave, because they are simply talk about the number of the roots. If they are talking about the what is the root at which the function value is something, then we have to solve this equation. Now you can see about that. Can you find the number of the positive roots? There is one change in sign, 1. How many negative roots are there? If I, what is the value of the f of minus x? Minus x minus 1. So that means 0 number of the negative roots. Fine. Then what, as I told you, whatever the behavior of this small function of odd function always be the same. So number, there is no negative roots are there. No negative, no real root is positive, but we get a real root as a positive. In this case also we see exactly one real root is negative, exactly one, but you can see in this case is a 0. Also if you look about there, if I change them as I change this to be here, fine, so we will get more than one negative roots. Fine, we can see we will get more than one but he said exactly, so these two options I already discard them. Exactly one real root is positive, that's, you can see exactly one real root is positive, all the real roots are positive, and you can see from here is the simple. So A and B are the correct answers of this problem. Okay, look at this another one. Consider a function real to this. Okay, can you think about any of the function whose second derivative should be greater than 0? If I choose f of x is my x square, so definitely it's a greater than 0. What is the f dash is? 2x, but domain is my here, which can be greater than 0 or here, so it means this function is not applicable. Can you think about the function of exponential? So clearly say this is always greater than 0. This is the graph of this. So clearly say derivative is also greater than 0. Second derivative is also greater than 0. So I can substitute here x approaches minus infinity, e raised to power x, e raised to power minus x over, sorry, f dash is e raised to power x. So that means limit x approaches minus infinity to e to power x. So that will be 0 is the right answer. That's true, because if you look about that some another function, like say it will be 3 plus e raised to power x, which is also greater than 0, derivative is also greater than 0, and so on. And then if you substitute 3 plus, then it will be 3 plus 3 6 plus e raised to power x. So what is the answer of this? It is 3 plus 0 is 3. If you consider f is my 7 plus e raised to power x, 7 plus e to power x, then your answer will be 7. So you can take any number in between 0 to infinity is the right answer of this problem. Okay, look at this another one. F is a continuous function such that f of x is x plus 1. Do you understand what kind of the function is here? This is a periodic function. Fine, periodic function with the period 1. Clear? Also the function is given as a continuous. So what does the property continuous plus periodic function, what does it mean? Any function which is continuous and periodic, like sin x, like cos x, and anything, so that is always bounded. Fine, if you have the continuous function, if you have the periodic function, this is always bounded, but the first option said it is not necessarily bounded. Now there exists of this, so can you choose any of the function which is a bounded or continuous or periodic? Any constant function. Fine, constant function is bounded, constant function is periodic as well. So I can simply say f of x is 1. So now look at the second option. There exists, so what is the left hand side is 1, right hand side is 1. Do you get a unique x naught? No, because 2 plus pi is also equal to f of 2. 3 plus pi is also equal to f of 3, because the function is my constant. So there exists a unique, cancel 1. There exists a no x naught, but that's wrong. We may obtain many x naught. If I choose f x naught is 3, so 3 plus pi and same. So there exists basically infinitely many, because constant function has period not defined, so infinitely many are there. So the D is my right answer. Okay, f is a continuous function such that of here. Always remember, whenever you have the function from f of x dx is 0, it will give you f is identically 0 for all x in the domain, provided one condition will be there, the limits a and b should be finite. So you can see a and b are finite, this condition satisfied. F of x is 0, what does it means? F is my 0 identically on the whole R is the correct answer. F satisfying the first, that is identically 0 on this is a subset of R, but not identically, but not is a wrong answer. F is taking a both positive and negative value, that's wrong, because f is basically a 0 function. F is infinitely many point but not identically 0 is the wrong answer. So A is the only correct answer. F is an infinitely differentiable function, that means f is infinitely continuous as well, which satisfies this property such that f is not a polynomial, f is a linear function f of this. Which things come in your mind when you look about this term? That is the Lagrange mean value theorem. Fine. What is the Lagrange mean value theorem suggested you? F of a, f of b minus of this, which is equal to f dash of c, where c belongs to the open interval a comma b, and you can see this is my c. Fine. Now, what is the condition for the Lagrange multiplier? You can see continuous function and differentiable function. Very simple. You choose any function which satisfies this condition. Say x square. Fine. Is it satisfied this function? B square minus a square over b minus a. What is the derivative of this? Is a 2 times c. Fine. So clearly say this property is satisfied. Fine. So it means f of x is equal to x square satisfied this equation. So f must be the linear, but it's a non-linear. F is not a polynomial, but it's a polynomial. F must be the polynomial of degree greater than 2, but he said is equal to 2. So less than or is equal to 2 is the remaining option is the right. Okay, now you can see the Rolle's theorem. What is the property of the Rolle's theorem is f should be continuous. So what is the property of the continuous? So it should be continuous at x is equal to 0. So if you substitute here 1 plus 0, it should be 1 minus 0, 0 plus q. So q should be 1. So q, second component, this option cancel, this option cancel. Second property of the Rolle's theorem is f is differentiable. So if I found the differentiable of this, it is my 1. It is, if I open this bracket, it is my px plus q minus px square minus qx. So what is the derivative of this? P minus 2px minus q. Whenever x is greater than 0, x is less than 0. So at the point x is equal to 0, what is the answer of this? 1 p minus q. So p minus q should be 1. This is a 1, this is a 3, is a cancel. Otherwise q is equal to 1, so p will be 2 is the right answer of the problem. Okay, look at this one. A function you have to target about here. So look at that. X cube plus x square from 0 to 2. F of t dt is my x square. Then your target is to find the fx. Fine. What is the fx is? It is not given. So what I can do? I can differentiate this function with respect to x. Fine. So how I can differentiate this? It is come to be the partial and it will be here. So the right hand side is my 2x. This will be the 0, so I can substitute the upper limit directly. So x cube plus into x square into derivative of 3x square plus 2x minus substitute the lower limit f of 0 into 0 derivative will be 0. So that will be 3x square plus 2x into f of x cube plus x square is 2x. Now your target is to find the f of 2. What should be the value of this? I can take x is equal to 1, then it is f of 2, so it is my 5, f of 2 is my 2, so f of 2 will be 2 over 5. I need the f of 12, so how I can make that 12? It will be 2, so then it's a 4, 12 plus 4, 16, f of this, it is my 4. So what is the f of 12 is my 1 over 4. Fine. Now I need to find the g. So g function is given to be here. Since the function is already given to you, I can simply integrate them. So this is my t cube over 3 from g of x to 0. It is 9 times x plus 1 cube. So it means 9x cube, which is 9 3 27, x plus 1 cube. So what is my gx? Gx will be 3 times x plus 1. So what is my g of 2? 2 plus 1 3, 3 into 3 is g of 2. So 2 plus 1 3, 3 into 3 is 9. Now I can substitute here. It is 2 over 5 plus 9 plus 16 into 4, 13. So it's a 13 point, this is a 0.4, 13.4 is the right answer of this problem. You can write in the 2 decimal places, that's the correct answer. Okay, f is the continuous function. You can choose any of the continuous function. Fine. F is a continuous function, so I can choose f of x is my any continuous function. Fine. Is it okay? F is a continuous function. Then I can okay. Can you think about this? Is my here? Is there continuous function? Yes. But is it satisfied this property? No, because f of minus 1, I can take minus 1 from here. What is the answer of this? It does not belongs to this. Fine. You may take a function is x square. Yes, it is always lies in this case. So you may consider this function. There is no issue about it. Fine. But the easiest one is I can take it as a constant. Which of the following function is not true? So I can find this value. What is the f of 0? 3 plus 3 over 2. 3. Yes, this is the correct statement. But we need a false statement. This number is 3 into 3 is again a 3. Is a correct statement. What is that? It's a minus 1 to 3 of dt is a 6 function. F of x is 6. There exists x. Can you find any of the x? Can you find any x so that f of x is 6? No, because this is my constant function. So it means this is my false statement. Look at this one. This answer is again 3. Yes, this is my correct statement. Always consider the function which is much easier than. You may consider this function, but that will take a lot of calculation as well. Okay, look at this another one. Okay, that's the most easiest tips I will give. There is no need to solve them. Whenever you have the integration of this function x of n, f of x dx, the answer is always 0. Fine. Second tip, whenever you multiply this by n into this, fine, it is always be my f of 1. There is only one condition is f should be continuous function on the closed interval 0, 1. Always remember this limit should be from 0 to 1. Now you can see, can you compare the fx? F of x will be here, and you can see this function is my continuous on 0, 1. So now you can see n is multiply. Sorry, I forget to take the limit. Fine. This is the limit. Limit n approaches infinity. So now this is the n. So answer should be f of 1. So what is the f of 1? 1 over 2 is the right answer. There is no need to think about that. So here is n should be start from 0. Similar question is asked here. That is x raised to power n minus 1 n over 1 plus x, and you can see n start greater than or equal to 1. Fine. and the sequence Sn. Again you can see, now you can see n is greater than 1, so basically this is a constant value. Okay, remember you can't return like of this. In that case n should be greater than 0, but here n is my 1, so that's why I have taken n minus 1. So you can't return like here. Fine. So can you compare what is my fx? Fx is n, I can taken as the outside, again my here. Then the sequence, what is the limit of this sequence is limit n approaches infinity of Sn. So I can see x of n minus 1, 1 plus x. So what is the answer of this? F of 1. So what is the f of 1? 1 over 2 is the right answer. Always remember this, the simplest shortcut tricks I have given you. Remember, whatever the n is given to you, it must start from the 0. In this case, it starts from the n minus 1. So that's why it starts from the here. Okay, f is a non-constant continuous function. So I can simply choose, this is my non-constant, such that f circle f is my f. Is it satisfied? So basically this is my here. So that means this is my fx. It is satisfied. Fine. Now, okay, this is already given to you. Then e of f. Do you know what is the meaning of this? This is, what is the meaning of that? This is basically a fixed point. Fine. This is the fixed point. How many fixed point of the straight line on the closed interval 0, 1? Every point on the closed interval 0, 1 is the fixed point. Fine. So that means e of f is my 0, 1. So e is neither open nor closed. E is in interval, fine. E is the empty, need not be the interval, is cancelled. So B is the right answer of the problem. Okay, look at this another one. Consider the property the value of the expression is a finite. What is the meaning of the finite is? Supremum of this function is some constant k. That's the meaning of the finite. Fine. Then gy is defined to be here. Which are the following? G even, f even. Okay, firstly I will think about here, because this does not involve the g. I need the function fx. Can you find the value of the fx from here? Fx should be greater than of xy minus k. Then I can divide it by mod of x. It is greater than of y into x by mod x minus k over mod x. Now take the limit when mod x approaches to the plus infinity. So this value will be my 0. Fine. This value will be my, it's a plus infinity, so it's my plus 1. So this number is my greater than y. What is the value of the y? Y is in the real number. So that means this will goes to the infinity. So that is the correct statement. He said negative. That is a wrong answer. It will goes to the minus infinity when you take the limit as minus infinity. So that's why this is cancelled. Okay, now whether the g is a even or f is even. What is the meaning of the f is even? Firstly, g is even means your target is to prove this one, and if you want to prove gy is odd, your target is to prove this one. So I think that's a very simple. I can start from this part. G of minus y. That means supremum of x belongs to the R is a minus xy of f of x, and f from the first case f is even. What is the meaning of the f is even? I can return xy minus this function is f of minus x. Now x belongs to the R. If I put minus of x is say another variable z, which is also in the R, so that means supremum of z belongs to the R. It is my zy minus f of zy. So what is the definition of this? This is basically a g of y. So what does it mean? G is my even function. So g is my odd function is the wrong answer. Okay, which of the following is my true equation increasing, decreasing exactly one root. Okay, I consider this is my ax, this is my bx minus 1. What is the rule for the increasing and decreasing? You start from the derivative. So ax ln of a, bx ln of b. Fine. So what is the a is 5 over 13, b is 12 over 13. Now you check whether it's a less than 0 or greater than 0. What is the ln of 5 over 13? It's a less than 0 because this number is less than 1. So this number is my negative. This number is my negative. This a raised to power x is always positive. This is always positive. So this number is always less than 0. So what does that means? This is my monotonically decreasing sequence. So this option is cancelled. This option is correct option. Now exactly one solution and exactly two solution. Fine. So clearly say this is my continuous function. Fine. And you prove that it is my monotonic function. Fine. So what does it mean? What is the theorem is? If the function is continuous, if the function is monotonic, then it has at most one real solution. Fine. So exactly one real solution. That means this option is the correct option. This option is the wrong answer. Fine. So that is a continuous and monotonic. You will get as one function. That is almost one real solution is the right answer. Okay. This is my limit n approaches infinity. I can written as a product of 1 minus 1 over n square. Fine. N start from 2 to infinity. Very simple. Always remember, whenever you have the function of this form, fine, the limit is existence when. So remember, this is existence, that means this is the sequence. This is existence means this is the convergent. This sequence is convergent if you prove that this term is series is my convergent. Fine. So firstly I will check whether this condition hold or not. So what is that? A n square. If you compare them, it is 1 over n square, which is convergent by p test. Fine. So once you prove that it's a convergent, then the limit n approaches infinity of this, which is equal to a of minimum number. If I start from the n is 2 to infinity, 2 to n, so that smallest number is a2. So can you compare what is the an? If you compare them, an will be 1 over n. So what is the a of this smallest number? 2. 1 over 2 is the right answer, because this is my decreasing. Because of this negative is a decreasing, that's why it's a a2. If it is a positive, then it's a maximum. Okay, which of the following condition is not satisfied? Does not exist. Very simple. First option. So when infinity is infinity by infinity form, I can apply the L'Hopital rule. It is 1 over x over 1. Again it's infinity by infinity form. So 2 1 over x over 1, which goes to the 0. But he said does not exist. F dash x, if you take the derivative, 2 ln x over x. So now again it's infinity by infinity form. So 2 over x divided by 1. So that will goes to the 0. But he said 2. Now f of this, so that means ln of x plus 1 whole square minus ln of x whole square. So I can apply a plus b, a minus b, a square of this and ln of x plus 1 plus ln x. Fine. So this will be ln of 1 plus 1 over x, and this is ln of, again I can take x as a common, this plus ln of x. I can take because I can make them a pair. So this number is, if I open this, it's a log m into n. So it's a twice of log x plus log of 1 plus 1 over x. Fine. And this number will be 1 plus x. Now we all know if I multiply by x and divided by x, this number will be my 1. Why? Because I can return this number is here, and this number is when n x approaches infinity, that will be my ln of e. This is a 1. Fine. And from this case it will be 2 ln x over x plus ln of 1 plus 1 over x over x. So this number, now you can take the limit as n approaches infinity. This is infinity by infinity form, so it will be 2 by x over 1. Again it's infinity by infinity form, so it is 1 over this and minus 1 over x square. So clearly say this number will become 0. This number is also goes to the 0 because this is my 1 and it goes to the 0. So yes, 0 is the right answer, and this is not existence is the cross answer. Which of the following statement is my false? Again it's a infinity by infinity form, so I can apply this. So when you take infinity, it goes to the 0. This is the correct statement. Again it's a infinity, so I can return is a 1 over x here, e raised to power this. So it is my infinity by infinity form, minus 1 over x square, e raised to power this, minus 1 over x square. So again it will goes to the e raised to power infinity 0. He said no. Is it a 0 by 0 form? No. So I can substitute directly as a 0. So it will be 0, and it is the only right answer because sine 0 is 1 and it is a 1, which is a 1, which is a false statement is the right answer. Okay, f is given to be here, then inverse function. Okay, firstly you can find the inverse function. How you can find that? I can simply take 2x is y, so x will be y over 2. So what is the domain? When x is 0 to 1, y belongs to the 0 to 2. Fine. Then I can take 8 minus 2x is y, so x will be 8 minus y over 2. What is the domain of the y is when x belongs to the 0 to 2, 2 to 3, so it is a 4 minus 4, and when you take 3 is a 6 minus 8 2, so y belongs to the 2 comma 3. Now clearly say what is that? Does not exist. That's a wrong. It's a existence. Fine. Now they are talking about the continuous. Whether it's a continuous, you can see at the point 2 at y is equal to 2, upper limit is 1, lower limit is 8 minus 2 6 by 3, which are not equal. So that means is existence but not continuous. So existence and not continuous is the right answer of this problem. So look at this another one. I can write firstly this into here plus 3n over 3, 2 raised to power n and 3 raised to power n. We all know limit of an as n approaches infinity will be 0 if a is less than 1, infinity if a is my greater than 1. So what I can do, I can divide it by 3 raised to power n, so that this becomes my here. Fine. So I can divide it by this number. Clear? Now you can take the limit as n approaches infinity. So this number is 0 if this number is less than 1. So 0 plus 3 over 0 plus 1 is the right answer. Okay, look at this another one. This kind of the question is very important from the examination point of view, and you can solve it in a very simple manner. Look at the first option. Take any number in between them. It's a 1.73 divided by 2, that means 0.8. You can choose any number in between them. 0.86. X is greater than 0, x is greater than 1.8, sorry. Fine, and so on. So firstly I can choose x is my 1. Fine. What is my f1? Is a 2 over f3, fine. What is f2? It is log of e3. What is my f3? Is my 2, fine. So can you find the value of the log of 3? So let me calculate it quickly. Log of e, just wait, what is that? It's a log of 3 divide log of 3. This number is 0. To the base 10, okay, to the base e. So okay, this number is my 0.66, this number is my 2. So first of all, f1 is less than f3. F3 is less, okay, this number is lies between here. 1 satisfied this. F1 is less than f3, fine. F1 is f3, fine. What is f2? Can you calculate a log e3? So you will get this number as 1.0986, because you have the calculator in your examination as well. So what is the relation you have obtained? F1 is less than F2 is less than F3 when x is equal to 1 satisfied. F2 less than F1 cross. X is greater than 0.5. F1, okay, I can also check it. What is the F1 plus F2? What is the F1 plus F2 is 2.66. What is the F3? If I divide it by 2, it is my 0.5. So it is not satisfied. This option is cancel out. F1, F2 is less than, again this option is cancel out. Only this option which is left behind here. Again I can check it. If I take x is my 0.5 in between them. So what will happen if I take x is my 0.5? Fine. So this will be f1 will be 1 over 2. F2 will be log of e2 and f3 will be 2x. It will be 1. So f1 is less than f3, but it's a f3 is less than f1. This option is also cancelled. So where is the error is? Can I check this value again? f1 plus f2. So I can check this value. What is the ln log e3? So I wrongly this f1 plus f2. This f1 plus f2 0.66 plus 1.09 is less than of 1. Is it true? f3 by 2. f3 by 2 is my 1. So again it is, so which one is the right answer? f2 is less than f1. f2 is less than f1 is wrong. f1 is less than of f3, fine, but f3 is less than of f3 is, no, this is, so none of these is the right answer of the problem. Chalo, because none of these satisfied, so none of these is the right answer. Okay, which of the following is true about 0 to pi by 2? So again I can choose the one particular value. So in order to substitute here, I have to choose the x is 0 to, this is 3.14 over 2, 1.57. So firstly I can choose any number, say x is equal to 1. So look at that, it will be my root 2. Is it less than of 1 plus 1 over 2 minus 1 over 8? So you can use again your calculator. This is my 1.414. This number will be 1 plus 0.5, that is a 1.5 minus 1 divided by 8. So this number is my 1.375. So clearly say it is not satisfied. This option cancel out. Look at this one, 1 minus 1, 0 is less than of ln 3. It's satisfied. Fine. But we can't correct them. Okay, look at this one. Because it's angle, I can choose any angle in between them. Say pi by 4. If you choose pi by 4, it's a tan pi by 4 is 1, which is less than of pi by 4, which is the wrong option. Because pi can never be less than of this. Fine. Now, I can choose pi by 4 here. It's a 1 by root 2, which is less than of cos 1 by root 2. So again, if you choose the angle, because now this is, you have to set your angle in the radian form. Fine. So if you calculate this value in the calculator, firstly you have to fix into the radian, then it is 1 divided by root 2. So I use my calculator to compute them. This number will be my This number is my 0.76024, and what is the 1 by root 2 is 1 divided by root 2 is my 0.707 here. So this is satisfied, this is also satisfied. Fine, you can choose any other values. Otherwise, because it's open intervals, if I choose x is near to the 0, fine, or okay, for this case it's a sign. We know this in the first quadrant. In the first quadrant, sine of x is always less than of x. Fine, then I can take the cosine function on the both sides. Cosine is my decreasing function because the derivative of the cos is minus sine x is less than 0. So it means cos of sine x, because of the decreasing function, it is greater than of cos x. So it is true for all x. Similarly, you can see about here, this function is always greater than of this one. So A and D are the correct answers. Okay, look at this one. Fx is greater than of gx for some are there. Again, you can choose any of the number in between them. Say x is 0. Fine. So what is the fx is? Cos 0 is 1. This is also 1. So both are the same. So we can't say anything about that. Then how you can say about this? Choose any number. Say pi by 3. Fine. So what is the f is? Is a 60 degree. Cos 60 degree is my 1 over 2. Fine. Then g will be 1 minus, I can change into the pi by 3 over square divided by 2. So I can calculate this value. It's a 1 minus 3.14 divided by 3 and square divided by 2. This number is 0.45224. So f is my 0.5, which is greater than of this. So this number is cancelled out. This is my positive sign. Now fx minus gx. So if fx is greater than of gx by the first part, what does it means? Fx minus gx is always greater than 0. Fine. So if I consider this is my hx, so that means my hx is greater than 0 for all x in this domain. Fine. So what does it mean? If you draw the graph from minus pi by 2 to plus pi by 2, it is always increasing. Can you find has changed sign? Can it change with the sign? What is the meaning of the change sign? It means at some point this value should be less than 0. Some point its value is greater than 0. But that is not possible because it is my increasing. So that means there is no change in sign. Otherwise, there is one more way. We all know what is the expansion of the cos x. 1 minus x square by 2, x square by 4 factorial, x 6 by 4, 6 factorial, and so on. So what is my fx minus gx? So clearly say this is my gx. So if you subtract them, f minus g. Fine. So if I take f minus g, it is my x4 over 4 factorial, x6 over 6 factorial, and so on. So which is even degree, and it can never be less than 0. Fine, because it's a positive number, it can never be less than 0. So again you can say it never change the sign. A is my right answer. Otherwise you can simply say from this concept, it is always increasing, so never be less than 0. Okay, for n is my natural number, for which other case is my correct? N is greater than for all n. Firstly, I can choose n is my 1. What will happen? This integration is x square plus cos theta of x square minus 1 into. So remember the integration is with respect to theta. So what is the first integration? X square is outside, it is my minus 0. It is x square minus 1 is outside, it's a cos theta. So what is the integration of this? It's a 0. Why? Because the integration of the cos will be sine from 0 to pi. Sine pi is a 0 of this. Fine. So this number will be 0. It is pi x square. It is a polynomial. But he said for all n, it is not a polynomial. So I can choose any of the other number. Say n is my 3. Fine. So what will happen if I choose n is 3? This is my cos theta, and this is I call as some another constant because it is integration of this. Fine. So what is that? It's a x raised to power 6. It is my cos cube into alpha cube plus 3a square b plus 3 this of here. Fine. Now you can see if you integrate them from 0 to pi, this number is again 0. Because of the 0 to pi, this number is again 0, this number is again 0. So you will get this is x raised to power 6 into pi. So again, which is a polynomial. So whenever I choose n is 3, it is not a polynomial. N is equal to 3, it is not a polynomial. Fine. N is equal to 4. Whenever you taken as a 4, what will happen? It consists of the power 4. Again it will be the 0. So this is also cancelled. C is the right answer of this problem. Okay, look at this another one. Whenever f and function a range of this. Okay. Always remember when you have the quotient of the supremum and the infimum, always taken the example of minus 1 the power n. But right now it's a 0 to 1. So I can choose my function is 1 plus minus 1 to power n. Fine. Clearly say its number is lies between, no, it is from 0 to 2. So I can divide it by 2. First case, for all x, it is also x, it is also x. So I can choose f and g both as the same number. Then what is the supremum of this? So this value will be either 0 when n is odd and 1 if n is even. So supremum will be my 1, infimum is my 0. So you can see 1 is less than 0, not possible. Now he said for sum. Now both have the different. For sum it said for all, but this example is not applicable for this because it said for sum. Fine. So what I can do, fx is less than of gx is given to you and infimum. So clearly say infimum of the r is less than of the fx for sum. Okay, fx is less than of the gx and gx is less than of the supremum. Fine. So that's a simple statement. G of x is less than again for sum. Again this is the same concept about that. Infimum of the rf is less than of the f is less than of the g, and g is less than of the supremum for sum. Now if you look about the third option, it is for all. There is some difference. It is for all. Now fx is less than of gy. Supremum. So definitely supremum of the f. Supremum is that is the greatest lower bound. It is less than of the gy. Fine. It is for all. Once this is for all, it is definitely be less than of the least upper bound. That is basically a infimum of this because it is for all. Fine. So it is the infimum of this one. So supremum is less than of infimum is also correct answer. So which is true statement. So B, C, D are the correct answers. Okay, which of the following is my, what is the round of this? Do you think which definition will work when you think about here? Function is continuous. Fx minus fa is less than epsilon whenever x minus a is less than delta. Fine. Now look at that. Function is my 1 over n. Fine. What is that? Firstly I can see about what is that f of x. What is the f of 1 by 3 is? 3. So 3 is my here. Fine. So whenever you taken as a 3, the corresponding function is 1 over 3. So can you find the range of this? This number is 4. This number is 2. So 2 will be my here. 4 will be this. So what is the corresponding number? This is my 1 over 4. This number is 1 over 2. So my domain will be here. Fine. Now your target is to find this interval. Fine. So what is the length of this part? What is the length of this is minus 1 over 3, 1 over 2 modulus value. it is 1 over 6. What is the length of this part? 1 over 3 minus 1 over 4, it is 1 over 12. Now what is the delta? Because it's a less than sign, so I can say it's a minimum of 1 over 6 and 1 over 12. Because we all know when you say mod of x is less than of a, mod of x is less than of b, how you can written that? It is minimum of a comma b. Mod of x is less than of this. So what is the minimum of this? It is my 2 over 12. So the answer is 1 over 12. If it is my greater than sign, then we have to take the maximum of this. So the right answer is 1 over 12. Look at this another one. F is infinitely differentiable. That means it is it's infinitely continuous also. F double dash has exactly two distinct root. Fine. That means if this is the graphically line, F double dash has two distinct root. It means F double dash will be look like say x into x minus 1, two distinct root. Fine. So what is the degree of the polynomial f? At least of the 4 degree. Fine. So I can say these are the roots of this my f. f1, f2, f3, f4. These are the roots of the f. Now f is my continuous function, f is differentiable function. So what is the meaning of that? By the Rolle's theorem, there exist roots in between them. That is called as say beta 1. There exists a root in between them, beta 2. There exists a root in between them, beta 3, such that f dash of beta 1 is 0, f dash of beta 2 is 0, f dash of beta 3 is 0. So that means these are the roots of f dash. Again, f dash is also the continuous infinitely differentiable function. There exists a root in between them called as a1. There exists a root in between them called as a2, which is the root of f double dash. That is my here. Then f dash has at most 3 distinct root. Yes, at most. It has at most 3 distinct root. Fine. F dash have at least 1 0. Fine. At least 1 0. Now, can you say about that? Look at that. I can see this example. F dash of this. Let me write at here. Now, how you can say that f dash has at least 1 root? If I look about this, if I differentiate, this x square is x cube over 3 minus x square over 2 plus 1 constant c1. So what is the meaning of that? It's a cubic, or you can say it's an odd degree. Fine. Once you get the odd degree, how you can say about that? F dash has at least 1 0. F dash has at least 1 0. Okay, fine. You can see it's a quadratic. It's a cube, x square minus x. It's a cubic, so it may have at least 1 root. Fine. Okay, fine. You can see c is my constant. Fine. If I choose this constant is say my constant as say 7. So f of 0 is my 7. Fine. How many positive roots are there? It has 2 positive roots. One this here. How many negative roots are there? There is a 1 negative roots. Fine. So the solution will be, okay, I can choose the function like this. Why there is need of the passing so the 0? I can choose the function like here. Fine. You can see f dash has this is the graph of the f dash. Then this is the root of f double dash. Now clearly say it doesn't touches on the x-axis. Fine. This is the graph. This is the value of, say, I consider function is x minus 1, x minus 2. Fine. This is say 1. This is my 2. So clearly say this is my f dash which never touches on the x-axis. F has at most 3 distinct root. Now you are talking about the f. if I simply say x into x, so x square minus x, f dash will be x cube over 3 x square over 2 plus c1x, f double dash will be x4 over 4 x cube over 3 c1 x square over 2 plus c2. Fine. Now you can see I can choose c1 is my 0. Fine. c2 is another number, say 10. So what is my function? x4 over 4 x cube over 3 plus 10. Now this is the degree 4. Fine. So what is the meaning of that? The graph will always be the form of this, but y is equal to 0, its value is my 10, so the graph will be look like say here. Fine. And clearly say it never touch on the x-axis, so that means it is no root. Again it has at least two distinct root because it never touch on the x-axis, so f is at least, the condition is at least, it may not be satisfied. So the right answer of this is my only A is the correct answer of this problem. We will see the next lecture on the power series. Till then you can simply scan and join my WhatsApp group. You can share my videos with your other friends. Thank you very much.